Greetings to you. Myself, Dr. C. Nityanandam, Associate Professor in Mechanical Engineering Department. In this video, we are going to learn about support reactions of the beam in the subject of engineering mechanics. What is a reactions and how to make the support reactions of the beam. Then what is a beam and what are all the supports and what are all the various loads are applying on the beam, how to calculate the surface support reactions of the beam. Now we go to the topic. In this subject, the engineering mechanics. So the engineering mechanics subject is in the second semester mechanical and also all the non-circuit branches. It is a common to non-circuit branches. Now I present this. What is a support reactions? First, what's mean by the support reaction? So the reaction force is already we know. As per the Newton's third law, the reaction force is created naturally. Now we discussed about what is a support reaction. Why we are calculating these reactive forces on the beam. If a number of forces are acting on a body and the body is supported to another body, then the second body exerts a force known as reactions on the first body at the points of contact, so that the first body is in equilibrium. So when the equilibrium state is, already we have studied in the second unit, the equilibrium of the bodies. Now some of the forces are acting in the beam is 0 and some of the moment is also equal to 0. So then when the body will be in equilibrium. So here the second body, we have to discuss about the two bodies, first body and the second body. So the second body is known as support. So the first body is a beam and the second body is a vertical column. It is for the support of the beam. So this second body is known as a support, and the force exerted by the second body on the first body is known as a support reactions. Then what is a beam? Beam is a horizontal structural member in a building to resist the lateral loads applied to the beam axis. So the lateral forces is applying on the beam axis, that means the vertical forces. The structural member which resists the forces laterally or transversely applied to the axis is called a beam. So in this diagram, these two are the piles or pillar or vertical column. So it is a beam. So now these two sides are, we have to, in between the two piles gap, it is a vertical column. So at the end of this vertical column, the beam is fixed on both the sides. Now the load will be acting on the beam. Now what will happen? The beam will be sometime deflected. So we have to avoid the deflection or any deformation. At the time when the body will be in the equilibrium, there is no deformation at the stage of the point loading or any type of load is applied. Then what are the various types of beam? So simply supported beam, overhanging beam, then cantilever beam, continuous beam, then propped cantilever beam. One side is fixed and another side the roller support is given. Then the fixed beam, both sides are fixed. So it is a hinged support, roller support. It is for the overhanging beam. Then this is a cantilever beam. It is one side is fixed, another side is free. It is a continuous beam. The best example is a bridges. Then what are all the various supports? So these are all the types of support. We are having generally 4 different types of support. And then we have to given the representation symbol, roller support. The symbol will be given like this. What are all the reactive forces is acting on the roller support? It is only the vertical reaction, because the roller is this will be the sliding motion. So the best example is a skating. And then the pinned or hinged support. It is having the reaction force is vertically upward force and horizontally towards the positive x direction. So it is having only one reaction. It is having only 2 reactions. And then what about the fixed support? Fixed support, when the reactive forces, vertical reactions are vertically upward, and then the towards the positive x direction horizontal force, and another one is a anti-clockwise moment. So all type of loads are resisting it, horizontal, vertical and anti-clockwise moment. Then the symbol support. It is having similar to the symbol support. It is having only one vertical reaction. So these are all the various types of supports. Then what are the various types of load is applied on the beam? Consider this. This is a beam. This is a roller support. It is a hinged support. So in this beam, 3-point load is applied or concentrated load. So the symbol is here. This will be the length and with the arrowhead. It is acting vertically downward. Sometime when the force is acting from vertically upward. So this is called as a point load. Then the second category is uniformly distributed load. The example is the sandbag. The equal weight will be distributed on the entire beam. So one sandbag weight is having some Newton per meter. So every 1 meter, one sandbag is placed on the beam. It is a uniformly distributed. So how to calculate the reaction? First thing, you have to convert this uniformly distributed load into point load. Otherwise we can't find the support reaction. So how to convert this point load? UDL from point load. So you have to calculate the total weight first. The W Newton per meter. It is having W is having some value, right? In terms of Newton per meter. This length will be given in the problem. It is a per meter, every 1 meter W Newton. So what is a total length? It is a total is a L. So W into L is a total weight. This weight is acting in center of the length. So where is the acting like this, vertically downward? It is a L by 2. From here to L by 2 or from here to L by 2. So we have to convert the UDL into point load. This is also called as a next important one. It is a uniformly varying load. Starting from 0 to it is having some value. So how to convert this triangular load or triangular shape of the load is converted into point load. It is we have to the point load is how to convert it. The point load is equal to the area of the triangle, total area of the triangle. We know half BH. So this H, it is having some Newton per meter value. It is 0. So you have to calculate 1 by 2 into base is, it is a L will be given in the problem, and then the half BH, this maximum load will be given. So you have to calculate the triangular area. So this is a total load. But in this case, How to locate the distance where it is acting? This total load is converted into point load, but what about the distance? From here to calculate it, it is a 2 by 3 into L, from here to 1 by 3 into L. So it is a centroid distance, maybe this point. So it is, you have to calculate 2 by 3 into L. So it is a centroid point. So towards the center, all the load will be acting vertically downward. What is the total load? It is very simple to calculate the uniformly varying load. Then these are all called as another important one is trapezoidal load. So UDL and VDL. Both are combined in the one single beam, that is called as a trapezoidal beam. See this example, it is a uniformly varying load, it is a this is a uniformly distributed load, it is uniformly varying load. Both are combined, that load is called as a trapezoidal. Okay, now this load is again converted into one single point load. How? Here the example is given. It is a 220 Newton per meter is acting vertically downward. It is uniformly distributed at the total length 6. So you have to calculate this first, this rectangular load or uniformly distributed load 220 into 6. So I think the 1320. So 1320 is acting in center because L by 2. L by 2 is a 6 by 2, 3 meter. Then another thing, the triangular load. You have to calculate the triangular load of PH. P is a 6, H is a from here to 670 Newton meter. So of PH value, it is a 2010. So this force is acting vertically downward. Now you take these distances here to 2 by 3 into 6. So you have to calculate, it is a 4 meter from here to F2. Now this F1 and F2 both are converted into point load. How? So you have to making the again the moment R into D, that will be equal to 3 into F1 plus 4 into F2. So you have to calculate the total value is D is equal to 3.6. So it is a 3.6 is a final point load for both the uniformly and uniformly varying load. So this red color, this R is a point load. So this is a method to convert the trapezoidal load into point load. That's all. Thank you so much for watching.